ARC and industry-supported research hub for basin geodynamics and evolution of sedimentary systems is a platform for developing technologies to better understand sedimentary basins. What's special about them? Most of Australia is covered by sedimentary basins, and there are nearly 1,000 basins worldwide. Many of the resources that are essential for life and our very own existence are found in these basins. They host groundwater and energy resources, and they provide structures for carbon disposal. Sedimentary basins today are a consequence of processes operating over geological time. To unravel their evolution, we create virtual worlds that reconstruct Earth's geography, help understand how deep Earth evolution interacts with the surface, and follow the path of sediments from mountains to oceans. Our software technologies look at the Earth in new ways, and they're all freely available on the internet, including Underworld, Badlands, SitcomS, and G-Plates. These open source tools allow end users to visualize the evolution of basins through time in the context of a changing Earth. And even better, they can also be used to explore other processes that are critical for building and maintaining a habitable Earth.
During my PhD, we discovered that the Great Barrier Reef was playing a very active role in shaping undersea canyons off the coast of Queensland. And this discovery would have been impossible without all the fantastic development of state-of-the-art codes during the Basin Genesis Hub project.
Ancient river deposits host important water and energy resources, so I use Badlands to study how and why rivers evolve through time. The BGH has created cutting-edge technologies that help us to better understand river evolution so that we can sustainably manage those resources.
The layers of sediments preserved in Earth basins document the evolution of past climate, sea level, and tectonic events, as well as the effect of mantle flow on the surface of Earth. By using Badlands, we can produce powerful insights by mapping how mantle flow has caused the Earth's surface to rise and subside through geological history.
So we use computational methods and the wide range of competencies inside the Basin Genesis Hub to develop open source software solutions that are then used to help researchers answering important questions about Earth or help them sharpening their question.
My work is to investigate the interaction between landscape and deep earth processes to identify and to sort the main drivers of erosion, sedimentation, and reverse reorganization. Together with Tristan Sal, we are creating open source workflows to be able to simulate regional basin evolution, like this one in South Africa, which can be used by others anywhere on Earth.
Some of the capabilities of the work we perform is that we are able to break the limitations that usually exist in the way of transferring knowledge to new people interested in earth sciences. The research we perform allows not only students but also everyone interested in earth sciences to visualize and to imagine in their minds something with more precision how dynamic and how alive are earth processes.
I use Badlands to model the erosion and deposition of mafic rocks in a catchment in Australia to better understand the carbon sequestration abilities of that catchment under different future climate scenarios.
Currently, there's a growing demand for base and precious metals in a wide range of industries like technology and infrastructure. I use G-plates and Pi-G-plates to look for new prospective areas to explore for copper and gold.
Over the past 5 years, I've been building and using numerical Earth models to study how the churning interior of our planet drives the long-term geography on Earth's surface. And I plan to build on this by modeling reef systems on the scale of the Great Barrier Reef, geological timescales, to see what drives the rise and demise of these immense ecosystems. In addition, these models give us actual insight on where we could potentially inject and store liquefied CO2 into the future to tackle climate change.
We use models of plate tectonic motions constructed using G-plates to drive models of mantle flow in SitcomS. In this way, we can build our understanding of how plate tectonics shape the evolution of the deep Earth, driving mantle plumes and volcanism at the Earth's surface.
With surface water supplies becoming more scant due to longer droughts, we must turn to groundwater to help support a growing population and agricultural industry. I use Underworld to simulate the groundwater flow rates within major aquifers in the Sydney Basin, so that we can more sustainably manage this resource.
Our Basin Genesis Hub is the first industry hub entirely built upon community software development, leaving an enduring legacy for the entire earth science community. Nolan Bushnell, American engineer and entrepreneur, once said, "The best ideas lose their owners and take on lives of their own." That's what we hope will happen to our software.